In this tutorial, we will create a simple piping and instrumentation diagram in Autodesk Plant 3D. We will use 2 tanks and a pump to build a basic process system. Under Area 1, create a new drawing. I will call it Tutorial. This is where we will draft the P&ID. After the drawing opens, switch into Model Space. You cannot create the P&ID directly in Paper Space, so double-click inside the viewport and work in the model area of the AutoCAD drawing. For this exercise, I will use the P&ID palette. If your interface looks different, use the workspace switcher in the lower right corner. You may currently be in 3D piping, so switch back to the P&ID workspace. I also recommend opening the Properties palette, because we will use it frequently while assigning sizes, line information, tags, and component properties. The first step is to place the equipment. I will create 2 tanks, Tank 101 and Tank 102. When placing equipment, you can enable the option to assign the tag immediately after insertion. Next, I will add a simple centrifugal pump and place it between the 2 tanks. The pump will be tagged as P101. Tag numbers must be unique inside the project, so choose the next available number if Plant 3D reports a conflict. Before drawing any pipelines, define the line properties. In the Schematic Lines tools, set the pipe size and the pipe spec or line settings you want to use. Once those are defined, we can start drawing the process lines. Thanks to AutoCAD Object Snaps, it is fairly easy to connect equipment items accurately. Start by drawing a line from the first tank to the pump. After the line is placed, open the Properties palette and check the connection data. Now assign a tag to the line. You can right-click the line and choose Assign Tag, or use the P&ID Annotate command. Both workflows can add the line tag. If the tag is incomplete, fill in the missing service and line group number in Properties. Once those values are set, the line tag updates automatically. Next, create the line from the discharge side of the pump up to the second tank. For this line, I will use an 8-inch size. Start from the pump discharge nozzle, route the line to the top of the tank, and finish the connection. The third line is a gravity flow line from the upper tank back to tank 101. After placing it, make sure all line tags are identified correctly. Use the same service where appropriate, then advance the line number for each new line. With the main process lines in place, we can add valves and basic instruments. To add valves, open the Valves tab in the P&ID palette. Plant 3D includes several generic valve symbols. Place the valves where they are needed on the line. Each valve inherits line information automatically, so you do not need to type the same line data into every component. Plant 3D also increments component numbers as you place new items. Now add a drain connection. Draw a short branch line from the main line, update its size to 1 inch, and place a globe valve on the drain. In the Properties palette, confirm that the drain and valve are still associated with the correct process line. The suction side of the pump is now complete, so we can move to the discharge side. Depending on your design, you may need reducers, strainers, expansion joints, check valves, and other fittings. To make the example a little more complete, I will add expansion joints on both sides of the pump. Place the first expansion joint near the pump, then assign or adjust its tag if needed. Then place the second expansion joint and add the tag annotation so it is visible on the drawing. The discharge header is currently 8 inches, but I want to show a reduction to 6 inches. Add a reducer from the fittings tools. If it does not rotate exactly as expected during placement, place it first and then adjust it afterward. Once the smaller side is set to 6 inches, Plant 3D updates the reducer orientation and the line size relationship. Next, add a check valve on the discharge line. Go back to the appropriate fittings or valve tools, find the check valve symbol, and place it in the line. After that, add another drain with a globe valve. Be careful when placing valves on short branch lines, because the line connection can disappear if the symbol is not positioned cleanly. Above the drain, I will add an instrument connection for a pressure indicator. First place the instrument connection on the line. Then switch to the Instruments tab, find the General Instrument bubble, and place it beside the line. To show the relationship between the pressure indicator and the line connection, create a mechanical link. Select the mechanical line or mechanical link tool, then connect the instrument bubble to the connection point. If the link route looks awkward, adjust the placement so the drawing remains easy to read. The discharge side is now finished, so we can move to the top portion of the system. Here I want to show an isolation valve and a vent on the upper tank line. Create the short vent line, then place a globe valve on it. Update the vent line size to 1 inch. You can also define end connections inside Plant 3D. For example, if a valve should have flanged ends, select the valve and set the end connection property to flanged. For small drains and vents, use this only where it helps the drawing. For the expansion joints, we can also assign flanged end connections. Select each expansion joint and set the connection type where needed. On the vent valve, I will mark the connection as socket welded, which is more suitable for the small connection in the example. The upper side is now covered. The last remaining area is the gravity flow line back to the lower tank. Add an isolation valve near the tank connection. We will not add extra drains here, so the line stays simple. To indicate gravity flow, use the non-engineering symbols. Find the slope or gravity flow symbol, place it on the line, and enter the slope value and direction. This makes the intended flow direction clear on the P&ID. That completes the simple piping and instrumentation diagram in Plant 3D. We created 2 tanks, a pump, 3 process lines, line tags, valves, drains, vents, a pressure indicator, expansion joints, a reducer, a check valve, and a gravity flow indication. In the next video, we will start modeling the piping system that matches this P&ID.